is Lorenzo Vecchi. I work in SecurityGen pre-sales. SecurityGen is a company specialized in telco cybersecurity. Today we want to talk about deployments of 5G core network. We want to touch the security perspective of this topic, of course, because this is where we work on. And this presentation is divided into 3 parts: an introduction that is about just to understand what kind of workloads or what kind of customers, telcos, operators are for public cloud providers. In a second section, we will see a very high level the security tools for cybersecurity that we find at public clouds. And in the last section, we'll introduce our solutions for securing a particular but very important layer of a core network stack deployment, also when it goes over on a public cloud. Okay, so let's start with chapter 1 to give a general introduction and to set everybody on a common ground for a common discussion. Okay, telcos as public cloud customers. Here today we will talk about the big public cloud providers, the hyperscalers. So I will not name them every time, but I'm thinking about Amazon Web Services or Google Cloud Platform or Microsoft Azure. Of course, there are other choices, but I mean, let's focus on these 3 dominant players. And let's talk now. In this presentation today, we will see a lot of information and news taken from our industry, basically. So and let's try to define at least a couple of large kinds of workloads that are specific of a telco, the telecom operator. And let's start talking about, first of all, the BSS, okay, before talking about core network. So BSS is all around the business support systems, which is a lot of applications, a lot of workloads, as we know. And well, in recent years, you see here, you see that on this page, we heard about many announcements regarding attempts to deploy these kind of applications on public clouds. Amdocs, in example, which is a traditional vendor in this area, has now a strong proposition regarding consultancy for moving workloads towards the cloud in partnership with AWS. That's suggesting that also Amdocs native applications could be transferred and run over a public cloud. Then we have other announcements like the one from Netcracker and Google for modernization of BSS and OSS, Telefonica and Google for, you see here, some specific billing platforms for B2B cases, deployed again, not on premises, at Telefonica premises, but on the cloud. Also tends to deploy billing applications on the cloud. I mean, operators are pretty jealous about billing, but here today, many vendors also saying, okay, you can run your complete billing application on a cloud, especially if it's offline billing that runs every in a while. This makes sense. So when an application manages basically business logic or a marketplace or customer contact or even billing today, well, we say that today the public cloud is a possible option for sure. Marketplace here, I mean, all the portals where you can buy the offers from the different subscriptions for a public subscriber of a telco. Customer contact, again, there is a lot, and there are a lot of nice applications, especially regarding recognition of natural language that you can find more easily and off the shelf at cloud providers. So, and also other applications are today very natural at public clouds. For example, there's been a really recent announcement from Vodafone and Google regarding a cooperation in analytics. Vodafone wants to use better all the data they have around subscribers, what they do, what they prefer, if they are satisfied, they are not satisfied, and so on and so forth, in order to set better offers, to be able to anticipate some dangerous behaviors like churn, in example. And Google is a very, I mean, natural partner for this, because Google has a huge experience on analytics. That's why these partnerships really make a lot of sense. But we also can read of other partnership like Telefónica Brazil, working with Microsoft to create platforms for interactions backed up by artificial intelligence algorithm. And you know that at hyperscalers, you find a lot of these solutions backed up by artificial intelligence. So when it comes to zero weight, when you really need to have immediate resources, because in example, you need to go fast to the market. When you need elasticity beyond what a telco can do, then you can go to the cloud. I mean, you know that procurement of hardware for a telco can be, I wouldn't say an issue, but a complicated process. It takes a while if you have experience in IT procurement. But also on clouds, you find a huge portfolio of applications in areas where a telco can have some difficulties. In example, you can think about Hadoop clusters if you need them, databases of all sorts. And when it comes to working on data, public clouds has really an edge today over purely private clouds due to their experience with data. Okay? And so all these workloads make sense when you think about moving them to a public cloud, especially an hyperscaler. But there are also other attempts for cooperation regarding public clouds and telcos. I mean, the public clouds are trying to stretch their presence closer to the telco private cloud. And we have to think about the new use cases brought by multi-access edge computing and 5G. They need extreme performance, they need a short data pipe, so they need that the applications are really close to the core network. Or sometimes if you have a concern about data ownership or application control, you might want that that data are within your premises. But anyway, you want to cooperate with a public cloud provider. So public clouds are extending their presence closer to the telco private cloud or closer to enterprise with propositions like the ones that you see on top of this bridge, like AWS Wavelength, which targets more operators, Outposts, which target mostly enterprises, and then you have the similar propositions by other hyperscalers. And each hyperscaler has its own recipe for this bridge and which functions to put on it. It can be only infrastructure stuff deployed at customer premises, like AWS Outpost. Sometimes today you have hyperscalers saying that are building new data centers distributed and closer to customers. They can do this on their own or in cooperation with operators. Sometimes they put on top frameworks for orchestrating the workloads like Google Enters, or sometimes even more with application DBs. So all these propositions are, of course, interesting but different as well. And we will talk about differences a bit later. Now, let's just enter into the discussion about cybersecurity with the basics, let me say, considering the infrastructure, platform, and software as a service models. And just considering two players here, the cloud provider and the cloud user. And the stack is simplified within basically the column here, the blue column, from physical security resiliency to computing, storage, and networking, up to data and identity and access management, which is the framework allowing you to define a project on a cloud, who can access, who can do what, also in terms of application to application authorizations. Well, in the infrastructure as a service model, as we know, the cloud provider only provides the computing, networking and storage, physical security, then virtual machines and containers. The rest is under final customers' responsibility. In the SaaS model, it's the other way around. So the final customer, the cloud user, is only responsible for data and setting up its identity and access management framework. In between, you have platform as a service where some network communication policies or applications have a shared responsibility because you can use some platform tools provided by the hyperscaler, but then you have to deploy them correctly to make sure that they are accessed correctly. So here you have an area of responsibility that is shared. That's why these boxes here are colored with a color from blue to yellow, indicating the shared responsibility. And in spite of these good rules, we also know that risks do not disappear because incidents can happen at public clouds too. The most common one is data leakage due to improperly configured data buckets. This is one of most common that you can read in the news. Of course, you can have exploitation of exposed encryption keys, an example, exploitations of weakly protected access credentials. So when it comes to credentials, encryption keys, these are areas where if you don't protect very well the way you work or your deployment, you are at risk. Then also outages due to internal events of the cloud provider can be an issue. Of course, here the big names try to avoid this situation, but they sometimes happen. Here I added the link of one specific incident. And these kind of situations invite a final user to define a disaster recovery strategy. Today, we don't discuss about disaster recovery, but disaster recovery is anyway an important piece of a security framework to make sure that you don't have all your workloads at one single data center within the same availability zone, but you distribute things smartly, let me say. Well, given this introduction, now let's start talking about the telco workloads. And before talking about core networks, when I speak about telco workloads of a telco operator, I have in mind at least two big classes. So not anymore business support systems. These are more IT kind of workloads of a telco operator. When I talk about telco workloads, I mean mainly radio access network and core network. Radio access network, you see here a picture taken from an Open RAN flavor, in particular the Oran Alliance one. This is a very hot topic in the RAN industry. On the core network side, I just displayed a 5G core network, just to keep it simple. Well, the key features of a telco workload are, first of all, the need for high availability, 5 nines. They are user plane intensive. They switch and route a lot of user plane packets. And they need to, nowadays, they need to be distributed, again, due to multi-exegesis computing or new 5G use cases, which need low latency. You think about, you must distribute these workloads in metro data centers when low latency is required, close to the tower, regional or core. For example, a UDM, which doesn't require low latency, that's a big beta database with subscriber profile, that can be centralized. But UPFs for MEC or for low latency must stay closer to the tower, at metro or even more local data centers. And let's see now what happened in this area. This is a study that we performed just trying to understand how the hyperscalers approach core network workloads. And we have identified 4 big classes. The first one is the do-it-yourself, mostly today addressing B2B market. So here we have the cases of private core networks or private 5G stacks deployed by an hyperscaler using their own capabilities. AWS has such a proposition, Azure as well. So the hyperscaler has enough experience, people, and wealth, let me say, to say, okay, I will develop a core network stack, of course, on my cloud, and I will sell it. This is the do-it-yourself approach. Another approach is the buy, meaning that this case is basically based on 2 acquisitions by Microsoft. In recent years, in the last 1.5 years, 2 years, Microsoft acquired Metaswitch and Affirmed. Metaswitch was in the industry since a while, more specialized on voice application. Affirmed was more in a startup phase with basically focus on data pipes, 4G and 5G core networks. Well, Microsoft decided to acquire those. So basically in their portfolio now you also have core network applications developed by specialists in this area. Partnership, this is also a very important square of this slide. Partnerships mean that big names, big telecom vendors like Ericsson or Nokia, or even niche vendors, less famous names, decide anyway to deploy their core networks on top of public clouds using some of the basics provided by the hyperscalers, especially virtualization, containers, and orchestration containers, usually this stuff. So And this is a very important box because you know that Ericsson and Nokia anyway dominate the industry, especially when it comes to consider large telecom operators. And these large telecom operators are willing to start moving things towards the cloud. They cannot do it by themselves without the support of the technology providers like Ericsson and Nokia. Ericsson and Nokia, due to this push, need to talk to the hyperscalers. And so we have this game, at least of 3 players, telco vendors, telecom operators, and cloud providers, going into a bit the same direction, and this doing partnership. The last approach is offer an open toolbox. Is more a sort of experimental proposal by AWS from 2 years ago. Honestly, I've never seen a real use of this proposition. But anyway, the idea is proposed in this white paper published by AWS that on Amazon or on any other cloud provider, you can find a lot of tools on top of pure virtualization or containerization. You can find all sorts of database, load balancer, message queuing systems, login system, whatever. So Amazon in this white paper said, okay, if you want to develop a core network, do it using our tool. A very, let's say, bold and brave approach. I haven't seen it applied today in the industry, but anyway, it's worth mentioning for sure. And one last thing, when it comes to do it yourself, is not only an approach of hyperscalers, but also some very advanced and pioneer operators try this approach of deploying their own 5G stack. It's not very common, let me say. Usually, most of the telecom vendors prefer to buy or acquire technology, but some of them say, okay, I will develop my own stack. We will not debate this so deeply today, but let's consider also, let's mention this possibility. Well, now let's go back talking about security of network workloads. Again, let's look at the responsibility metrics. This time we have more players because we have cloud providers and final customers, the ones using a core network service. In the middle, we have a telecom vendor, like Ericsson, Nokia, these names, and the telecom operator. Okay, I simplified the stack because on top of virtualization, I put only platform tools and telco workloads. And on top, you have, again, applications and data, always under the final customer responsibility. Well, let me say that the platform tools are open and available for a vendor to develop its own core network stack only in the offer an open toolbox model, the one that is fostered by Amazon in that white paper from July 2020. An approach that, as I said, I'm not aware, at least, has been followed in the market. Also because this layer is really critical for performance, assurance, and security. That's why it is usually hidden inside the telco workload. An example, the database, the backend database of a UDM or an HSS, usually it's inside the telco workload. Anyway, in the do-it-yourself approach, if the hyperscaler builds the 5G stack, of course, the cloud provider, the hyperscaler, is responsible for all the stack up to the telco workload. In the buy model, usually the final target is a telecom operator. So a telecom operator could go to Microsoft and buy the core network pieces that Microsoft has now in its own portfolio, having acquired Metaswitch and Affirmed. So the telco workload, the responsibility over the cybersecurity of the telco workload is now shared because the software itself is given by a cloud provider, but operations are under the responsibility of the telecom operator. When we come to the big partnership, this is the most complex situation, basically, because here we have all the players. For the basic, the foundation of the stack, we have a cloud provider. On top, always the final customers. And in the middle, of course, the telco workload security is under the responsibility of the telecom vendor, Ericsson, Nokia, or such names, but also of the telecom operator that uses this stack to provide services to final customers. Okay, so this is basically a customization of a generic IaaS, PaaS, and SaaS responsibility model, very specific for core networks. And let's stop for a while now, because we would like to propose you a poll, a few basic questions with one question basically with multiple choices. And Max, yeah, please, okay, let me comment what we ask you to evaluate. Basically, we would like to have your opinion regarding the future of network workloads at public clouds. If you think that the large traditional vendors, I don't know, Ericsson, Huawei, or this one, will dominate for several years, or if you think that public cloud providers or other niche players will erode the positions of the traditional telecom equipment vendors, or if you think that telcos will become more independent and will develop the 5G stacks on public clouds on their own. Please vote. Okay, it's nice to see that, well, this surprises me, honestly. I see that most of the voters think that the telcos will need to become more independent and getting more control of the software stack instead of buying it completely from the usual suspects, very well known in this industry, or buying these stacks from the public cloud provider. Okay, thank you for sharing this. It's really interesting and a bit also surprising. Okay, I think we have all the votes, more or less. Yes. So Max, we can continue. I will stop the, yeah. These are the results. As you see, the last option is the one that got most of the votes. And this is really interesting because I know for sure of some big names who decided to go this way, but usually it takes some bravery, let me say. Okay, now we can continue. So let's go on with the second chapter. Now we will review at very high level the security foundations, the tools that we find at public clouds. Well, talking about cybersecurity at public clouds would require 10 webinars, for sure. I mean, joking aside, here we will just touch some basic building blocks of cybersecurity at public clouds. So, first of all, identity and access management. This is the real foundation. You have to define very well the people who can do the operations, which operations every person having access to the project can do. This concept must be extended also to applications. You have to define this logic of access management also to communications between software entities. You can do it with IAM provided by cloud providers themselves, because you can decide, for example, if a virtual machine can have access to the services of another virtual machine or a database, or you can do it even at a deeper level using microservices and service frameworks, deciding there which microservice can talk to which other microservice, which piece of software can talk and access resources from other pieces of software. So these identity having to do with more human beings and access management, also including software entities, is the very basic of cybersecurity, because it gives you control of communications. Then for sure, we have in the portfolio of the cloud providers, you have a lot of tools and services for the management of cryptographic keys and protecting secrets, also backed by hardware security modules, hardware modules which are not really easy to access, and where you run applications in charge of secrets like encryption keys. You can also have possible integration with external key management systems to separate keys and data. Also, cloud providers give a possibility to buy managed TLS certificates in order to have authorities certifying the identity of the different applications. And so everything around keys and secrets is something that you find off the shelf. And the third big chapter is the one related to data. I mean, data is the other huge chapter regarding cybersecurity. You need to make sure that data access is properly configured, because as we said, one of the most typical issue or incident that you find at public clouds is that a data bucket is not protected. Someone is able to get in and data is stolen. So it's important that you use as much as you can encryption of data at rest when it's on storage, or even when it's crunched in memory, or in transit when it travels between sites or between instances sometimes. There are also services related to assured data location. I mean, today cloud providers, in order to comply with national or even industry regulations, let you choose in which country the data resides. You have trusted execution environments to protect highly sensitive data during processing, trusted platform modules to make sure that the boot process is secure and that the pieces of software loaded onto a public cloud deployment have not been compromised. Again, this is based and backed by cryptographic keys. So all the tools making sure that software and running software and data that is in use is well protected, is certified, has not been breached, has not been compromised, and so on and so forth. And these are the basics. But now it's also important that we have a look at more advanced tools. And here, what you see in this slide is basically a classification on 3 big classes of the different tools that you can find at hyperscalers, or generally speaking, at cloud providers. Well, let me say here, it's important to underline that these tools are not identical at all cloud providers. You could have a cloud provider A that has a strong tool for inspection and perhaps is a bit weaker on detection, or vice versa, or the tools, all strong at the same level anyway, are different. So it's not always easy to compare the features of similar tools of hyperscaler A and hyperscaler B. And this brings on a problem of portability, and we'll discuss it very short. So, but anyway, again, this classification comes from an analysis of all hyperscalers on all possible tools they have. So it's not related to one cloud provider only. And we can classify these tools, advanced tools, over 3 big classes. One is related to inspection, meaning that you have a deployment already, applications up and running, and you do something to try to intrude, to enter into this environment and see how it reacts. Inside this chapter, you could have also services like traditional, let me say, IT penetration testing. But in terms of tools, I mean, real tools that you find at cloud providers, you have systems to discover cloud resources deployed in a project, tools looking for common vulnerability and exposures as classified by the Mitri Foundation, trying to understand if there are some software packages having known vulnerabilities, in example. You have tools evaluating network exposure, trying to understand if some subnets are too open or it's too easy to enter into these, if you don't have any kind of filter from a front end for a back end, and so on and so forth. And after doing these activities, you also have a risk classification. You are able to understand if your project has been correctly deployed or if it has some wide vulnerabilities. And this is what goes under inspection. When we talk about detection, instead, these are all tools that enables you to understand if an attack or a malicious event is ongoing. They are based on extensive use of logging, so you must log as much as you can, access logs, API use, and so on. You have to be able to perform analytics on massive data amount. So on all these logs, you need to have also powerful signature-based techniques that on all these amount of logs are able to understand if there is a pattern matching an attack situation. And nowadays we know that these kind of detection tools are backed up a lot by advanced statistical analysis or by what we call artificial intelligence or machine learning tools. And with all of these, you are able to identify compromised accounts, instances, data. Then, of course, you have tools for protection, is the third pillar. So here we are talking about more traditional firewalls, like network firewalls, web application firewalls, and also measures against message flooding. So tools in order to protect against attacks based on a lot of messages. Well, now let's have a look at all of these in perspective, basically. So let's assume that you deployed a core network stack on a public cloud, perhaps following the NFV recommendations. I put the NFV stack on the left-hand side. Perhaps you used for sure you used infrastructure, because this is the bare minimum you can buy at the public cloud. Perhaps you used or not platform tools like DBs, load balancers. For sure, probably you use containers and container orchestration. Then at the side of it, you used all the security tools allowed by cloud provider, like nice IAM framework, data protection, keys and secrets. And on top, you use the detection and protection and inspection pillars with the tools available in the toolbox of your cloud provider. But now, let's see the final target. Final target is having a core network workload. Well, the core network workload, is it really protected if you did all the rest? From the point of view of inspection, detection, and protection, well, our answer is no. Basically, because the core network by itself has its own peculiar communication needs. And the one that we will focus mostly, but not only, is roaming. So the core networks communicate each with the other because people travel all over the world. And if you switch on your mobile 1,000 kilometers away from your country, you want to have similar or the same services you have at home. And you need communications over a very peculiar network here. I mean the IPX network. And if you don't protect those communications as well with the same pillars like inspection, detection, protection, perhaps you did a wonderful job protecting the basics of the stack, but the top layer is not. So no point in securing all this deployment if the signaling control plane is not protected, is unprotected, because the signaling control plane is what makes your network work. Also, it's important to say that, well, the protection of the signaling layer can be standardized because messages traveling at signaling level are specified by standards. Also, their cybersecurity aspects are under some recommendations. Here I'm talking about 3GPP and GSMA documents. So basically, it's even easy to port from one cloud provider to another if you want to change your public cloud provider. The protection of the signaling stack, because this is a standard layer, unlike all the other tools that you have for the layers underneath the core network. So also portability of this kind of protection is easy. Okay, so our message here is that software and cloud environment security is important, but it's not the whole story. You need to secure the signal control plane. Now, let's go with the second poll. And Max, if you can bring it on screen, I will just briefly comment and let people vote. I don't see it appearing, Max. Okay, thank you. So we would like to know what is the most valuable function for core network workload signaling security in your opinion, considering the three broad areas that we identified in the previous slides: inspection, detection, protection, or none of the above. Okay, yeah. You start voting it. Okay, I see that a combination of a function is what is getting most of the votes, even though detection and protection are getting some. Okay, a few more seconds, and then I think we can stop and share the results. Okay, I think we have almost all participants voted, right? Okay, let's share the results. Well, yeah, as expected, here I'm not surprised. Most of the voters said that the combination of the three functions can provide real security, even though there are some voters saying that the same level, detection and protection are important, are the most important, most valuable functions. Okay, thank you for sharing your point of view. And let me continue now with the last part of the webinar, and we will now present our solutions, SecurityGen solution and vision for the security at the top of core network stack, security of signaling. Okay. Now, again, we believe in the three pillars that we think are easily found at hyperscalers. I mean, inspection, detection, and protection are anyway good principles that you should apply also for core network signaling protection. For inspection, our solution is called the Artificial Cybersecurity Expert, ACE. For detection, we have an intrusion detection system. The brand name is Telecom Security Guard for continual and real-time monitoring of the network. For protection, for the firewall function, we have the intrusion protection system within the same Telecom Security Guard solution. You don't have to buy them together, but we propose also for interested customers to combine IDS and IPS together in the so-called next generation firewall, NGFW, because we think that there are some important synergies in the combination of these two entities. Now, having matched our proposition with basic pillars of inspection, detection, and protection, or IDP for short, let's see the solutions one by one. Let's start from the Artificial Cybersecurity Expert, which is the solution behind the inspection pillar. The easiest deployment that you can think about for such a solution is to make it work as a signaling hacker, someone who is connected to IPX network, and from there tries to launch attacks against core network assets. So in its most basic deployment type, ACE is deployed at SecurityGen data center. SecurityGen has its own connection to IPX providers. From there, we launch attacks that we call actually inspection plans against the core network assets of our customers using all generations of signaling. And I mean 2G and 3G, so SS7 with mobile and camera application parts, map and cap, tunneling protocols, and GTP, basically, and diameter for 4G. And we are ready also for attacks based on 5G signaling, I mean HTTP2, and we also have methods for the packet forwarding control protocol, PFCP, that is used between the session management function and the user plane function. 5G roaming, 5G SA, standalone roaming, is not used today. Still, 4G roaming dominates the industry, but anyway, our tool is ready for 5G. So ACE from our cloud, from our data center, launches inspection plans using all these protocols that I mentioned through an IPX connection and probes the reaction of the network. So ACE is a breach and attack simulation. It tries to work on full transactions, not only I send a message and I see if it goes through. It's backed by an extensive knowledge base, one of the richest in the market. We recently did a study, and we have really more than 200 attack methods, and the library will expand and is already expanding for 5G, and with suggestions given by customers as well, because we update our knowledge base with new type of attacks, also considering the needs of our customers. And the other important pillar is the very high degree of automation. This is a platform that enables you to perform audits whenever you like, instead of doing it once or twice per year buying a service. And this kind of approach has been actually awarded in the industry. Recently, just this spring, we had a couple of awards, one at Rocco, second place as innovators, and one as winners for innovation at Telecom World Middle East. So again, a large knowledge base, but that's not all. You must be able to put it on a platform that lets you use it easily in a highly automated way. So ACE performs real attack simulation, checks if there are threats in the mobile network infrastructure, provides also remediations on top, so you don't need a human expert to analyze the results of your signaling attacks, because ACE automatically creates a report, again, automation, and with, again, the help of all this large amount of automation, based on simply clicking, dragging, dropping things, not coding, no coding at all, well, you can turn security posture analysis into a business as usual problems. Operation. You can do audits whenever you want, instead of buying a service once per year, once every 2 years. A few screenshots from ACE. Well, how easy it is to create inspection plan. Here on the top, you have the library. You can see a snapshot of a piece of a library of ACE. You can select the message that you want to insert in the inspection plan. Here I selected this delete profile via NRF, which is for 5G. You edit, and this automatically appears in the list of methods for your inspection plan. After you have created your inspection plan, basically you launch it with a click. You have this run plan, this small button. With one click, you launch your inspection plan. So really, again, a lot of automation. And of course, we have also managed services to help you creating inspection plans if you're not familiar on how to do it, or even to run ACE on your behalf in a sort of, managed service way. Let's go to see the other pillar, detection. And we see the telecom security guard intrusion detection system. This time you need, like in tools on public clouds, where you need to log everything you do. Here you need to log all the signaling that goes in and out from some specific interfaces, especially international roaming interfaces. In order to do that, you just need basic technology that you find in every switch and router. I mean, you just need port mirroring. You send the copied, the mirrored traffic, signaling traffic to IDS. IDS analyzes it, identifies if there are ongoing attacks, and then provides you useful statistics about the health of your network from the point of view of signaling security. Again, IDS Key Functions. It has a huge knowledge base with 2,000 signatures identifying to attack, allow it to identify over 500 attacks. And this number will grow because 5G is getting more and more mature. The system allows you to do security incident analysis, even if you don't have firewalls. Well, with this tool, you can analyze all the signaling that entered through, in example, international roaming interfaces or even national roaming interfaces, and understand if some signaling messages were attacks or not. So it gives you full network visibility because it analyzes all signaling at critical interfaces, matching it with a knowledge base of attack signatures. The final step is adding a firewall, perhaps in combination with the IDS. If you have an integrated dashboard, the visualization and some other operations are easier. So, of course, you don't have to buy firewall and IDS from the same vendor. But if you're interested in this kind of approach, of course, we have a combined solution. Now you have a firewall as well. So you're not only able to identify attacks, but you're able to stop them. So to trigger rules, access control list of firewall rules. And again, the system gives you useful statistics to understand what entered, what has been blocked by firewall, which messages were used more frequently, and so on. And we will have a look at one of the screenshot of the dashboard. Anyway, IDS and IPS better together. Why we decided to develop IDS and firewall and put them inside the same solution? 1 + 1 greater than 2 with the slogan. Simply because if you identify with IDS a new kind of attack and you want to create a new firewall rule to stop it, with integrated platforms, you just need to do a one-click operation. You can really transfer the identified attack into a new firewall rule in a few clicks, let me say. So you can improve even the firewall configuration automatically. If you have different products, you cannot do it. Perhaps you have an IDS, you identify a new attack that bypassed the firewall, but then you have to tell the firewall guys, look, this specific event happened, please configure a new firewall rule. So it's based on human communications, and it's not automatic anymore. TSG has all that the security dashboard needs, let me say, because it has message level view of signaling attacks. Message by message tells you, gives you visibility of the attack, and you can click and see the main fields, protocol fields of the attack. This is not Wireshark, of course, you cannot go to that level, but at least the main protocol fields used for the attack are visible in the dashboard. You have statistics for the attack types, here based on different kind of methods, messages. You have severity level statistics, statistics about the potential impact of the attacks, like if these attacks were related to data leakage, frauds, subscriber denial of service, and so on and so forth. So a dashboard for the overall security. But anyway, nothing prevents that you integrate our solutions, TSG solution, with also an external CM. So if you have an umbrella system taking care of all the security of your networks, not only signaling, but also other pieces of a network, you can integrate our TSG with CM solutions and easily. Again, the power of IDS and IDP integration. In this window, you can see in the grayed out area an attack identified by the IDS component, the intrusion detection component. You see a message, a map update location request. Well, you want to stop this message, you just have to click this small button at the bottom of the screen where you have create firewall rule. You have a pop-up menu here. You can just accept the conditions. Automatically, you have the language, the coding language for creating the new rule. You don't have to write anything. You can just accept it or modify small parts, and then save the new rule. So from next time, this attack will not go through anymore. Let me now go towards the end of the presentation, talking about some pillars, or let me say the synergy of the pillars. Let's start about with talking about firewall tuning. Sometimes you deploy a firewall in a network. You think that the firewall gives you full protection, but it's very often is not really the end of the story. Firewall can be bypassed by special techniques based on tweaking the message content. And if you don't inspect the firewall behavior, you could have surprises. So, in example, you deployed an IPS firewall, signaling firewall in your network. You can use ACE to perform an attack playbook. Some attacks might go through, breach through a firewall. Then, using IDS, in example, that analyzes all the signal, or even using ACE, the replies that ACE gets back from the network, you identify the firewall bypass attacks. Then you can tell people in charge of the firewall to improve, enhance the firewall rules. When you have a new configuration, you can launch another run of inspection plan from ACE and make sure that attacks are blocked. So if you have an example here, ACE, you don't have to wait 6 months next time you buy a security service to make sure that your firewall tuning was successful. You can launch inspection plans after 1 day, after 1 minute, after 1 week, whenever you want, okay? And through automation, having predefined inspection plans, being able to launch them with 1 click, ACE facilitates a lot the inspection pillar, okay? Now, let's talk about 2 interesting use cases coming from from 5G, basically. These are a bit of a cutting edge of the technology, but we think that IDS and IPS can be useful also in private 5G networks. Let's start from a so-called SMPN case, a very ugly acronym, standing for standalone non-public network, meaning that this is a completely private network, usually it's a 5G network, isolated and serving the needs of a campus, a factory, in example, or a smart mine complex, this kind of use cases. Well, it is true that in this case, the service-based interface over which the different network function communicates is isolated because you don't have roaming in this case. Nevertheless, applications here using the core network are so delicate that if someone is able to penetrate into the IP networking and launch attacks against network functions, you are really in trouble. Sometimes you move from security to safety, because if you think of a factory where you have robotic arms moving around and you lose control, or someone is able to mess up with your normal working, you can have incidents involving human beings. So very delicate situation. So with an IDS, at least, you are able to have a watchdog on the SBI and make sure that nobody is injecting malicious signal onto it. Another interesting use case, again coming from 5G, beyond roaming, beyond the protection of roaming interface, which is the core of our solutions, anyway, is related to network slicing. This time I have, again, a piece of a network dedicated to an enterprise customer, but unlike the slide before where everything was private, this time we have a network slice. So we have what is called, again with an ugly acronym, public network integrated non-public network, PNI-MPN, which is usually deployed as a network slice. Of course, here you have some network functions which are common and given by the telco operator to all network slices, and some other network functions are instead private inside the slice. Well, why not introducing an intrusion detection system, and this time even an IPS, a firewall, at the entrance of the slice, in order to make sure that no cross-slice attacks are possible and that a critical slice is well protected. This is, again, an additional value, an additional possible use case for our solution on top of more traditional protection of roaming borders. Well, I'm at the end of a presentation here. I thank you, first of all. So, and let me stop, and we open basically to questions.